Question 7. So start off by drawing a sketch to reflect all the various forces. So kick off by resolving perpendicular to the plane, so allow us to work out what our normal reaction is. R is 2.77 newtons because this purple force equals this component of the weight, so 0.4 g cos 45. Now we can then move on to resolving in the direction of the plane. Obviously we have movement here, so it's not cancelling out the forces. We're going to have to use Newton's second, F equals ma. So we're travelling up this way, so our net force is going to be, we're travelling down. So we're travelling down. So our net force is going to be the component of weight less the friction. So 0.4 g sin 45, so this red arrow here, less the friction, which is 0.2 time, which we were given. We're given that the coefficient of friction is 0.2 times the normal reaction that we just worked out to be 2.77. That allows us, so that's the left hand side, the net force equaling mass times acceleration. The mass is 0.4. This allows us to work out that the acceleration is 5.54. Now we know our initial speed is 5, we know the distance travelled, s equals 2, we've just worked out our acceleration to be 5.54, so using v squared equals u squared plus 2as, we can work out v to be 6.87, and also using v equals u plus at, we can work out t to be 0.337. Now for part 2, we've now got it the other way around, so we've got a below b. So we've got the friction in the opposite direction. So now our net, so using F equals ma, we've still got our 0.4 g sin 45, but that's going now in the same direction. This weight component is in the same direction as the friction. So because we're moving upwards, so the friction is now downwards. So the two forces are in the same direction. I'd like to think of this. You don't have to do this, but I like to think of this as being the negative force equaling mass times acceleration, so 0.4 times the acceleration. This then gives us a deceleration of 8.31 meters per second squared. The answer will allow you to have 8.31, so don't get too bogged down with the relevance of this minus, but I like to think of everything sort of uphill being the positive, so hence why this is a negative force. So anyway, we've got an acceleration being minus 8.31. U is still 5. We're travelling up the hill until we stop, so we know v is going to be 0. So v squared equaling u squared plus 2as allows me to work out the distance I travel up the slope before I stop. This is actually only 1.50 meters, so not the 2 meters between A and B, hence why I do not reach B. Now for part B, calculate the difference in the momentum. Well, to calculate the difference in the momentum, I need to know the speed travelling by the particle as it comes back down the slope and passes A again. So considering, just looking at the downward journey only, as I go from, well, I didn't quite get to B, so from B, the direction of B to A, but I'm starting from 1.5 meters up the hill. Okay, so I've got an acceleration, because I'm going down the slope now, of 5.54 from my calculations in 1. I've got a distance travelled being 1.5 meters. I know my initial speed as I travel down the slope, because I've just come up poised and then gone down. I know my initial speed is 0, so using v squared equals u squared plus 2as, I can work out that v equals 4.08. Now I can calculate the difference in the momentum, sometimes called impulse. So the difference in momentum is m times v minus u. So my mass is 0.4. Now be careful about this change in speed. Obviously I was going up the slope at 5 and then down the slope at 4.08. So it's really 5 minus 4.08, which is 5 plus 4.08. So it's very important you understand that plus sign there. This gives us a difference in momentum impulse of 3.63 kilogram meters per second.